Here we're given a rational function and asked to find the domain and any vertical or horizontal or oblique asymptotes. So there's a guide for how to do this in the notes here. It says that if we're able to take a rational function and write it in reduced form so that all the common factors have been removed, then there will be a vertical line at x equals c if and only if c is a real zero of the denominator. So the easiest way to identify asymptotes would be by graphing the function and looking at the graph. So I'll go to desmos.com and let's type in this function. Alright, so we see that the graph is heading toward infinity at an x value of -3. It's heading toward infinity on the left side of -3, but it's heading toward negative infinity on the right side of -3. So if we just type in x equals -3, this blue line is a picture of the asymptote that the function is approaching here. It looks like there's another vertical asymptote at x equals 3. Yeah, so those are going to be two vertical asymptotes that we can identify. However, even though the graph method shows that there's likely an asymptote at -3 and 3, we should analyze the actual formula mathematically to see if that's definitely the case. So the way we do this is to try and reduce the fraction to its simplest form, seeing if there's any common factors in the numerator and denominator. So that numerator, x squared minus 2x minus 8, could be factored into x minus 4, x plus 2. And the denominator, because it is a difference of perfect squares, it could break up into x plus 3, x minus 3. So we see that there's no factors that would cancel here. So with that in mind, the fraction is fully reduced. And so what we have to analyze is the denominator to find the vertical asymptotes. So what you do is you set the denominator equal to 0. And any zeros of the denominator are going to be vertical asymptote locations. So I'll rewrite this in its factored form. X plus 3 times x minus 3 equals 0. So by the zero factor law, x plus 3 has to equal 0, or x minus 3 equals 0. We can solve it by subtracting to reveal that there's a 0 at -3 and also a 0 at 3. So these are going to be the locations of vertical asymptotes. Now we know that a denominator of a fraction cannot be 0 in math, or else it would create an undefined answer. So the domain of our function cannot include the x of -3 or 3. So that makes our domain from negative infinity to negative 3. And then we're going to skip over the negative 3 using a union here. We'll go from negative 3 to 3, and then we'll use a union again to state the rest of the domain, which is 3 to infinity. So if I want to draw a picture of the domain on the graph itself, the domain does not include negative 3 or 3, so we'll just put open dots there. But the domain includes everything else. So that's the domain. From negative infinity to an x of negative 3, from negative 3 to positive 3, and then from 3 to infinity. There's nothing in the numerator that would restrict the domain. There wouldn't be any other problem other than just the denominator being 0. So that's the only thing that'll interfere with the domain. Oh, they also want the location of horizontal asymptotes. The directions for this say, consider P to be an nth degree polynomial, and Q can be an mth degree polynomial. So they're talking there about the powers of x, where the biggest power of x in the numerator is called n, and the biggest power of x in the denominator is called m. So for my problem here, we have x squared on top, so n is the power of the x, which is 2. And then we have x squared on bottom, so m is that biggest power of x, so that's 2 as well. So n and m are 2 for my problem. It says here that if n is less than m, so if the numerator power is less than the denominator power, then the horizontal line y equals 0 is going to be a horizontal asymptote for the function. If n is equal to m, which is the case for my problem, a horizontal line can be found by dividing the coefficients of the two polynomials. My coefficient for the numerator polynomial is 1, and my coefficient for the denominator polynomial is also 1. So for me, a(n) is 1, and b is also 1. So if we just divide those, y equals a(n) over b will give us 1 over 1. We have a horizontal asymptote at y equals 1. So let's look at the graph and see if that's right. So in the program here, you can just type y equals 1, and yeah, that looks correct for a horizontal asymptote. And that's it. There's no other asymptotes.